Next, let's take a look at how to write a simple C++ program. We won't have to write a whole lot of C++ programs in this course, but in other courses you might need it. And it's always good to know how to do this on a Linux system. Even if you know how to use Eclipse, it's always good to know how to do things like write C or C++ programs using just the terminal, VI, and the compiler. Okay, so just like before, let's do a VI, and let's call this program first, might as well, .cpp. Although you're not limited to what file extension you can use with the C++ program, this is the most common one, so might as well go with that. There are alternatives. Okay. So just like with the C program, we need an include. This is just like the import in Java. And here, it's a little bit different from the C program. And the object of this is not to turn you into expert C++ programmers, so I'm not going to go over and explain every single thing in this program because it's just sort of too time consuming. So I'm going to do the same kind of thing, that is print out a message using the insertion operator and streams. So it's a little bit different from the C program. Okay. So I'm going to print out a message and display a new line. And return 0, meaning that everything worked. Okay, so I'm not going to explain every single thing. If you want to learn C++, you might want to take the data structures course, something like that. I hope I got everything in this. Hope I got everything all right. So here I am. The main thing you want to get is just that you can use VI to edit a C++ program. You don't need Eclipse. You save it to disk. Do a quick ls. There's our first .cpp. And now let's compile it. So you can use the same steps, G++ -c first.cpp. Oh, no errors, good. I was expecting at least one error. If you do an ls, you will see the first.o. It's similar to what we got with xyz.o. And now let's compile it all the way down to an executable code, G++ -o. I'm going to say, I'm going to name the executable. Well, let's not. Let's just say, let's take the default. Let's see what happens. G++ first.o. Okay, didn't give us any error messages. Good. And now let's take a look. Things are pretty comparable. You have a minimal C++ program. It takes about 100 bytes, comparable to the 78 we needed for C. Our object code compiled down to almost 2 kilobytes, a little bit bigger than what our xyz.o file was. And our executable is about a little bit bigger than the C executable file, but pretty comparable. So if you get something like this, you know that you're on the right track. So can you run this? Sure. You can run a.out. Then you need the /a.out. Okay, and there it ran. It just printed exactly what we asked it to print. Whoa, what happened? Oh, first.cpp. Okay, so we asked it to print out hello CSI is 248. There it is. Okay, so those were the basic steps, and now what I'm going to do is, just like in the book, I'm going to introduce an error to see what happens when you get errors. So what I will do is I'll just insert a character somewhere. Let's just say I put in an F over here. Stray character. Let's see what happens if we have an error in our program. So I'm purposely introduc+ing an error just to see what happens. So I'm going to remove a.out. I'm going to say G++. This time around I'm going to say, okay, I want to create an executable called first using first.cpp. Okay, it's not going to work because we introduced an error into first.cpp. So let's see what happens. Aha. Okay. So it says error, and if you do an ls-l, this first.o, you can see it was generated before the modification time of first.cpp. So this is the old one. So it didn't actually generate this. So let's, to make doubly sure, let's remove that. First. And do the compile step again. We get the error. Do an ls-l. We see that there's no .o file. Okay. So oftentimes you will end up with a medium-sized C++ program or C program with many errors, and one error at the very beginning can cascade and give you many error messages. So like the book does, what we want to do is we want to save those error messages. So if we do something like this, like output redirection, and save it to a file called errors, assume that there's no file named errors in your current working directory, that's good. So watch what happens when you do this. Although we wanted the output to go into errors so that we can look at it later, what happened was the error still popped up. And if you do an ls-l, the file errors has nothing in it. So what happened? What went wrong? Well, what happened was these messages go to, it looks like they're going to the same place as standard out, which is the terminal, but it turns out it goes through to a different channel, quote-unquote channel. It goes to standard error, and so what we have to do, if you want to guide the errors into the error messages from G++ into a file, we have to use this. So standard in is 0, that's the keyboard. Standard out is the terminal, that's 1, and standard error is 2. It's also the terminal, it turns out. In Java, you might have seen the standard error shows up as red text in your console output. The same idea. Standard out shows up in Eclipse as black text, that's normal black text. And then standard error shows up as red text. Here in these terminals, unless you do something special, they both show up as text in the terminal. Okay, so let's try this. Now, the errors didn't show up in the terminal, so we're hoping it'll show up in the errors file. Sure enough, there it is. There's some text. And now we can cat it out. So if we have hundreds of errors, we can page through them and see what was the earliest error and fix that. Okay, so this is called redirecting standard error to a file. It's very useful when you're compiling. Okay, so let's take a look at the notes and see what other details we can get from the book. So we wrote a simple C++ program just like this, pretty much. We had to pound include IOStream. That's like, just like in the C program, we had to include standard io.h. We have a main, int main, and print out various messages using streams and console out. Cout is console out. End line is a new line, just like sort of like we did in the C program. And then we return 0. A lot of people just get annoyed with this notation return in parentheses 0. Return is not a method or a function, so I tend to use return space, whatever number, but you can do what you want. Okay, so you try this on your own, type in the source code, use, remember that case is important, you want to use lowercase. In C++, it's mostly lowercase languages. Almost all the keywords that we will commonly run across are lowercase. There are some that are uppercase or partly uppercase. And use the C++ extension. It turns out that C++ is a superset of C. So any C program is, you can say in some ways, is also a C++ program. You cannot say things the other way around. But any C program is also a C++ program. So you could take your C program, let's try that, and compile it using C++. So you could take your xyz.c and say g++ minus o xyz.c. So you could take a C program, use the C++ compiler to create an executable file. Let's just remember the sizes and see if anything changes. This was 7157. Nope, nothing changed except the time. I believe this is a new time, so let's check the date and time. Yeah, so it did create an executable. It was exactly the same size. So it did exactly what the C compiler did. So you can use either G++ or GCC with C programs. You want to stick to GCC for C programs. I think it might save you some trouble. If you have a C++ program, you want to give it the file extension .cpp. Some people use .uppercase C, 2 C's, both uppercase. Some people use .cxx, but I think let's just stick with .cpp for all our programs. So to compile, you do the same thing as in CC. You say G++, and by default it creates an a.out file. The book says a.exe, but just ignore that. It's a.out. And to run it, you have to say /a.exe. And we will go over why that is. There's a lot of security things where you don't want it to just be able to run anything in your current working directory. You want to say /a.out in our case. Okay, so go through these steps. These are all very nice things to look at. We went over basically all of this. You remember you can use output redirection with your own programs just like you would. Now the main problem is, of course, you have to have a /. The book doesn't have it, but this should say // first, and // first greater than and the name of the output file. You don't have to say / here, but you do at this point. Okay, so you can cat your C++ programs. You can introduce a compiler, see what happens, fix it. That's what the book goes over. You'll get an error message like this. And so, like we saw just now, we can use error redirection, say 2 greater than, and then pipe and get that output into a file. And then we can look at that file later. Okay, so that's redirecting standard error. So read up about it. It's pretty straightforward. All you need to do is 2 greater than. Okay. There are some other utilities that we will use for compiling. We will use make. We won't use the SCCS utility. It's available, I believe, but make is what we will use, and we will see how to use it in the lab. So if you have questions about anything that we've gone over, definitely ask in class or use the discussion forum. And next up, we'll see more C programs.